Great. Thanks for the introduction, Omar. And thanks everyone for joining today and taking time out of your busy schedules. I know Diogo and I are really excited about this topic today. So why don't we jump right into it? Next slide, please. Great. So we've designed today's webinar to be educational with practical information you can apply on your upcoming projects. And we'll cover off a few key topics today. So first, we'll introduce the concept of IoT, or Internet of Things enabled construction management. We'll then take a deeper dive into construction risks and opportunities IoT technology can help mitigate and unlock. And we'll touch on the process for implementing IoT enabled technology on your next project. And finally, we'll also leave some time for Q&A as Omar pointed out. So let's start with a preview of the top 5 construction risks we most often see at Brickeye. So those are environmental pollution risk, environmental hazards risk, concrete risk, water damage risk, and what we call building interior and fire risk. So this isn't an exhaustive list by any stretch, but it represents really the key areas where we see the adoption of IoT technology adding significant value today. So we'll take a deeper dive into each of these as we go through the webinar. So before we jump into it, for those that aren't familiar with Brickeye, I'll take a minute just to briefly introduce the company. So Brickeye, we're based in Toronto. We've been a leader in IoT and data analytics since 2014. Our focus is really all about empowering our customers to build and manage their projects safer, smarter, and better. And we do that by providing risk mitigation technology as a service. So IoT-enabled sensors, advanced analytics that enable decisive action on the job site in terms of risks, and helps inform best practices across your portfolio. So several leading GCs and developers are using Brickeye for the construction of multi-residential and commercial buildings, infrastructure projects, and some of our solutions also extend into remote monitoring applications for property management and even infrastructure assets. Next slide. So what is Internet of Things, or IoT enabled construction management? We really see it as the next iteration of risk mitigation and productivity for construction. So you can think of it a little like a building automation system for your construction site, right? We don't think twice about using building automation systems as our eyes and ears to manage finished buildings. So at Brickeye, we're taking the same approach for construction. We're bringing together a wide range of ruggedized IoT sensors and data analytics into one integrated platform, which is essentially providing you with an intelligence layer for your job site. And we see 2 big drivers really for the adoption of IoT at the job site. The first one is it can deliver significant improvements in construction risk mitigation. So this diagram, actually developed by Aon, illustrates what we call the mitigation delta of IoT, or in other words, the difference in claim size, you see that gap on the left, resulting from IoT discovery of a loss event versus a human discovery of that event. And so IoT can help discover the loss event faster and sooner, which can result in significant reduction in claim size. So a great example of this, kind of illustrated there on the right, is a burst pipe or a major water leak during off hours. So the IoT sensor can detect the event long before a human is back on site to discover it. Better yet, using IoT sensors integrated with devices like automatic shutoff valves, you can take action immediately to contain and minimize the damage without the need for a human to be on site at all. And as we're seeing in the industry, with water mitigation deductibles just tripling in the last 5 years alone, now being going up from 25K now up in the range of $250K for a first loss, or even $500K deductibles for subsequent losses on a project. Detecting and taking action on events sooner can translate into really significant savings on insurance, as well as avoided damages, rework, schedule delays. You get the idea. The second driver for IoT technology adoption at the job site is the opportunity to outperform, or in other words, kind of deliver ever improving value. So as we move up the pyramid there on the right-hand side, take data and alerts from various point solutions at the project level. We integrate those to generate insights and project trends on risk, as well as looking at performance metrics. So the diagram on the left, talking about productivity and quality, safety, environmental sustainability. This project data can be aggregated at the portfolio level and can really help your team inform best practices across the whole enterprise. So as a next step, I'll pass it off to Diogo here to talk about how it all works and comes together.
Thank you, Alex. So in a high-rise residential or commercial project, we typically install over 10 different types of sensors that are spread out across all the construction site. These sensors are constantly feeding data to our cloud server, our Brickeye software running in the background there, checking if, all those thresholds to see if there's any disaster recipes cooking up. Is it too noisy? Is there a potential leak? Is the air healthy to breathe? From the user's perspective, the superintendent, the project manager, they're getting historical and predictive reports at 5 a.m. in the morning, real-time alerts, and access to an online dashboard and a mobile app. Next slide, please. Here we see, once again, the top 5 construction risks that Alex mentioned earlier. We dive a little deeper to see how these risks are more probable and more impactful in specific phases of the construction schedule, right? Environmental risks like noise, vibration, dust start early on during demolition and excavation and needed to be monitored all the way to the end of the project. As your schedule moves forward, concrete becomes the biggest cost driver. Pouring your raft slabs, your foundations, your typical floors becomes the biggest schedule risk. And once your electricians are running in, but your envelope is still open, rainwater starts to become a big safety and quality problem. And then once that envelope is all the way up and that microenvironment is in place, drywall and millwork trades start coming in, we see multiple building interior risk haunting those expensive finishes. Next slide, please. So our environmental sensors provide analytics to monitor all pollution risks that can affect the construction and the neighboring environment. You're very familiar with noise, dust, vibration, and sometimes even light coming out of the crane. Contractors have been implementing noise mitigation plan, dust control plans, vibration monitoring as norm in city constructions. Our sensors have been adding an additional layer of compliance and reporting, right? We see continuous stories of community hearings stalling the start of the construction project. Bylaws are requiring more and more elaborate noise mitigation and dust control plans. We're seeing neighbors escalating noise and dust complaints, calling bylaw officers to come visit, submitting phone evidence. And in response, we see city hiring more and more bylaw officers and using those ink pens to frequently stab $100,000 fines. So contractors now can use our system not only to follow bylaws, but to show proactive environmental responsibility, right? Those noise reports, they follow the city thresholds using decibel A curve over 10 minutes that really averages down the loud noise spikes. Contractors come back to us actually shocked in how compliant they have been. Next slide, please.
Great. So Diogo talked about some of the risks there around noise compliance. Now I'll talk a little bit about some of the additional advantages and opportunities around noise mitigation. So noise exemption permits are actually a really great example of how mitigating environmental pollution risk can actually generate significant gains on your project. It's not just a compliance issue, right? There's actual advantages you can derive from this. So in this case study, extended community consultations resulted in a pretty significant delay in terms of construction start. So the project was already behind from the start. What the customer did was they included IoT-enabled noise monitoring and mitigation as part of a comprehensive noise mitigation plan, and they applied for an early work exemption permit with the city. So granting of that early work permit actually enabled the project to gain 2 additional hours each day, 10 plus hours a week, resulting in significant scheduling efficiencies and project gains, from reduced construction costs, even to savings in terms of financing interest charges, because they were able to advance the schedule from that perspective. So definitely some big ROI, and not just a compliance issue when it comes to noise. Next slide.
Definitely, Alex. And I like saying, ask not what your construction site can do to the environment. Ask what the environment can also do to your construction site. Every month or so, we see that crane operator park the crane, climb down, talk to the swamper. The day is over, right? Wind speeds exceeds 30 kilometers per hour, safety first. But that individual's decision impacts the entire logistics and financials of the whole project. Who keeps record of that wind speed? How critical is this piece of information? Where is it registered, and how is it communicated between all the construction stakeholders? So wind speeds are not the only critical weather data to have, right? Concrete trucks are on the way, it suddenly starts to rain. Can they be sent back? Who's going to pay for that bill, right? Or weather day that you called out where the sky fell in your construction site, but not in the other side of town. Now there is that back and forth discussion to see if it was a legit call. So our weather stations have been a critical instrument for real-time on-site conditions, providing weather analytics and precise forecasts. Next slide, please.
Great. So flipping to the other side of the coin again, just talking about some of the additional advantages and opportunities. In addition to mitigating risks like crane collapse, this example here really highlights the advantages associated with micro weather monitoring. So this includes informing the appropriate selection of concrete mix design based on the localized temperature at the site, right? And you may have a number of different concrete design mixes ready to go, depending on the local temperature. And so being able to understand those conditions and selecting the right mix can really make a difference in terms of your quality and the curing strength maturity of your concrete. Coordinating of trades based on the site conditions, or being able to replan based on changes in conditions. And Diogo alluded to this, but just the value of being able to maintain a historical record of conditions at the job site looking back can really help resolve disputes around non-working days claims, which can often happen between construction management firms, subcontractors, that kind of thing. Next slide. So when we think about concrete risk, we think about a few different risk types. So quality, achieving poor maturity or strength, or even some of the risks associated with third-party testing labs. These can represent pretty significant project risks. So in-place monitoring of concrete temperature using distributed sensors can mitigate surface cracking and rework. And you see some examples in the diagram there of a concrete node, and it's embedded in the concrete, taking real-time temperature of the concrete there, as well as monitoring some of the environmental conditions or areas around the concrete curing process itself. Using the maturity method, we can also calculate the strength of the concrete in real time, avoiding the potential for concrete failure. You're stripping the forms too early, you haven't achieved strength and maturity, in particular during cold weather pours. And in situ monitoring can also mitigate potential delays and added costs associated with third-party lab testing as well. So next slide.
Thank you, Alex. There's so much to concrete. I just feel that you and Amir can have a Netflix series, 8 episodes just on concrete.
Well,
So
I
let's
could,
talk.
I could, and I can also, I can also do the flip side of this coin on the concrete side too, just to finish it off, and then I'll pass it to you. So on the concrete side, there's also significant advantages in a couple main areas. One is around productivity and cost. So actually being able to strip forms sooner using maturity monitoring versus relying on cylinders. And doing that, you can save an average of 2 to 3 days per pour. And that really starts to add up. You've got tens of pours, or even, large projects, hundreds of pours really add up to meaningful schedule advancements. And then the other area, thinking about energy and also sustainability, is around energy efficiency and carbon savings. So being able to reduce the fuel use by optimizing the operation of heaters in forming zones. We talked to one contractor that tells us in the winter, they spend up to $40,000 a day just on fuel use alone, just for heaters. So being able to really optimize the operation of those heaters, based on real-time information of the concrete and the forming zones, can really not only save a ton of costs, but also reduce the environmental footprint of the project and the emissions as well. So now I'll pass it off to you, Diogo, to keep going.
So insurance providers are now very keen on contractors having not only a water mitigation plan, but a water mitigation system to de-risk their portfolio, right? I used to say water is the new fire, but no, water is the Freddy Krueger terror movie, which creeps up on you when you're sleeping. It's either coming from a pipe burst, vandalism, faulty design, extreme weather conditions. Brickeye has been installing flow meters to pinpoint leaks or any abnormal water movement, even before commissioning on temporary water runs, after commission, before occupancy. We also install presence of water sensors in critical locations where there's an increased risk of pipe leaks, pipe bursts, like temporary water runs and washing stations. These sensors can trigger a human response, or they can activate an automatic shutout valve system. We can additionally put sensors around expensive and sensitive equipment like electrical risers, elevator pits, electrical rooms. Our ultimate goal here is not only to avoid the leak from actually happening, but coming back to what Alex said earlier on the Delta, right? Enabling a human responder to minimize the damage of that leak. Next slide, please. And here we see just a typical flow sensor installation around a hot and cold water main on a mechanical penthouse. This was installed during the Christmas holidays, and just gave the contractor their extra assurance that everything was safe during the holidays. And this actually maintained itself a few months after occupancy. Next slide, please. The interior building environment also has its own risks. Space heaters are not only used to prepare concrete beds, but they also help softening that mud for drywallers, keeping the humidity in par for the millwork. While the building's HVAC still can't be turned on, the building's micro environment has to be artificially controlled by these dragons. Once that envelope is up, temperature and humidity sensors inside a building help reduce rework risks, increase the quality of those interior finishes, right? We actually add a few also carbon monoxide sensors and temperature sensors that help contractors really manage energy consumption, reduce fire watch staff, and increase site safety. Next slide, please.
Great. So thanks, Diogo. Here we've included a summary of the various risk categories that we talked about, the IoT solutions and some of the typical locations where they would be deployed. We often get those questions on a project, as well as the typical monitoring periods over the course of a project. So, and again, depending on the risk you're looking to mitigate, that monitoring period will vary. Some of these devices are on, installed for the course of an entire project. Some of them, and as Diogo alluded to with water, for example, once water service is connected, obviously you would start monitoring for those types of risks at that stage. But it'll vary depending on the risk and the type of devices you use. And we've also summarized the different risks that are mitigated in these different areas, as well as some of the additional advantages that we highlighted here. And so this can be a really good reference guide when we think about using IoT technology on your next project. And it's worth mentioning here that the obvious thing when we think about IoT technology deployment on a project is during construction itself, right? That's obvious. But the other areas where Brickeye works really closely with its customers is in the earlier phases of a project as well. So thinking about the early on in the estimating, the bidding phase. So providing you with risk mitigation guides to help your estimating teams think about the different risks that a specific project or project type might be exposed to, and thinking proactively about including the use of that technology as part of your estimates and as part of your bids to the client. If you're a construction manager or a GC bidding into a developer, being able to give that developer visibility early on, that you're thinking about these types of risks proactively. And then we move into the pre-construction stage. We start planning for things. And even there, when we think about securing insurance for the project, being able to work with our customers to provide them with project-specific risk mitigation plans to really dive into the project and specifically outline what exactly is being deployed, where, for what period of time, the risks that are being addressed. And that can really add a lot of value as forming part of a larger insurance application package with carriers that are looking to understand the risks that they might be exposed to on these projects. And then obviously moving into construction and the actual deployment of the technology itself and the benefits that it can drive on site. So I'll pass it to Diogo just to speak to the next slide, just around the process.
Yeah, you stole my thunder there a little bit, but I'm just going to dive a little deeper, Alex, on what you talked about, as next steps of creating that risk mitigation guide or plan that you pointed out, right, where we sit down and recommend sensor bundles and use cases that are applicable to a specific site. Will help each site determine what are the project-specific risks that it needs to mitigate, right? Superintendents, project coordinators, PMs all have time to analyze our recommendations on how long each sensor has to be installed and in what phase and at what cost, right? Every construction site, as you mentioned, is different. So some project managers might need presence of water sensors, in the risers only for a 12-month period while that envelope is open. Others might want a different solution, right? Flow sensors immediately after water is commissioned to pick up any abnormal water movement at nighttime. So in these risk mitigation plans, we recommend the most applicable sensor type, the safest and less destructive mounting solutions, the most applicable networking where we can provide signal in parking level 5. We recommend different types of installations, different maintenance costs, and more importantly, we integrate the human response plan to pre-establish alerts and thresholds, right? Of course, we can have an automatic shutout valve, but if the security guard doesn't know that he has to turn off a valve, counterclockwise, he might actually be opening the valve and increasing that water leak. So we're very diligent in fine-tuning these risk mitigation plans with the field team, right? And the end of our mission, right? We want to enable the site team to put their best foot forward and in the most cost-effective way.
Great. And I think with that, Omar, we'll pass it back to you. Thank everyone for their time there, and open it up to Q&A. Leave a lot of time here to help add value and answer some questions here.
Great. Thank you for that excellent presentation, guys. We've had several questions come in, so I'll start with the first one here. Do most contractors wait for concrete test results to come back prior to stripping forms?
That's a great question. I'm happy to take that one. I mean, typically right now, the main process is using cylinders, right? So you'll pour concrete cylinders, a set of them, you'll send them to the lab, and then you'll break them depending on the type of mix and when it's expected to achieve target strength. It might be day 1, day 3, day 4, day 7. And so you're essentially you're waiting for the lab to break those cylinders and call and say, hey, you've achieved target strength, and you're ready to strip forms. Where we see a significant advantage, what I was alluding to there, and understanding the strength and maturity of the concrete in real time, is that when you have a mass pour, just due to the volume of that and the temperature that the concrete is reaching in situ in that large volume, it's going to achieve that in place concrete is going to achieve target strength and maturity sooner than a small volume cylinder that's in a lab, different conditions, and it's not really representative of the larger concrete pour. And again, on average, typically you see you're achieving target strength 2 to 3 days sooner than what the cylinder break tests are showing you at the lab. So there's a huge advantage there in being able to use in-place concrete monitoring, not only for a quality perspective to measure temperature differential to avoid cracking, things like that, but also from the standpoint of maturity and strength and being able to strip those forms sooner. And that just means you're moving on to your next pour and the structure's going up faster. So there's a huge productivity gains that are possible there. So hopefully that answers the question.
Great, thanks, Alex. This next one has to do with water mitigation sensors. So typically, how much water mitigation sensors do I need on site for my high-rise project?
Yeah, that's a tough question there. Every project is different, but we usually recommend around 8 to 12 sensors to start off with, installed in different phases of the construction project. 2 presence of water sensors, usually around electrical risers. We can install 4 presence of water sensors in electrical rooms where there's expensive equipment. We usually put 2 presence of water sensors around the temporary water runs on the stairs. 2 to 3 flow sensors around temporary water runs, hot and cold domestic runs. And we can even move forward depending on how much we want to mitigate risks. We can add sensors around the PRV closets and comm rooms, and typically 12 to 8.
Okay, great. Thanks, Diogo. Another question that came in. How do contractors who use prefabricated concrete benefit of your sensors?
Yeah, so when you think about precast, right, which is a whole other kind of area versus in place, pouring of the concrete. There's definitely opportunities there. If you're a precast company, to take advantage of concrete monitoring as well. It's done, obviously where the concrete's being poured at the precast plant location, rather than at the construction site where those precast elements are then delivered to. But definitely there's an opportunity there from a maturity standpoint as well. Just using a single point sensor into kind of representative precast elements to understand once it's achieved strength that you can strip forms, but also be able to move those precast elements around so they can take the force of movement without damaging them, and that can really benefit your operations in terms of really reducing the cycle time on those precast elements, right? So now instead of doing maybe 2 batches a day, you can squeeze in a third batch, right, and be able to really increase your productivity there. So that's definitely an area that's available, and we have a number of really great concrete experts that are on our team. And if there's questions around how we can help you on whether it's precast or in place concrete monitoring specifically, as Diogo said, we could spend a whole 2 hours just talking about concrete because it's such a huge topic. And we'd be happy to put you in touch with those folks as well after the webinar to help answer any questions on that.
Great, thanks, Alex. The next question is, prior to construction, does Brickeye get involved in the estimating, bidding, or pre-construction stages?
Yeah, it's a great question. As I was alluding to earlier, we definitely do get involved, and we actually find that is a really great place to get started as early as possible, right? Because as you know, there's a number of different teams, departments within GCs that are thinking about these projects, and the estimating bidding team is working early on, gets handed over to pre-con, and then ultimately a project team gets assigned to actually execute, right? And so having communication between those teams, but also from Brickeye's perspective, being able to support those different phases is really key. We're quite flexible, and we get projects all the time. Some that are really early stage saying, "Hey, we're just estimating bidding this. We want to make sure that when we put this bid in to our client that we've thought about risk mitigation. What are some of the things that we want to incorporate into the project?" And that can really help you differentiate as a construction manager or as a GC to show the developer, the owner, that you're thinking about these things and thinking about ultimately the successful completion around these projects. So that's a big differentiator that can help you win more projects. And then once you've actually won the project and you get into pre-construction, again, there's an opportunity there that's typically where from a project insurance perspective, you're going to go get builder's risk, whether it's the developer owner that's securing the coverage, or in some cases it's the construction manager. But you're going to be able to include a risk mitigation plan, for example, as part of your insurance application package. And that's something that we help customers with all the time. And they can submit that and secure more competitive additional bids in terms of insurance coverage. And finally, obviously on construction itself, as we talked about today, just being able to deploy the technology there, get you real-time information, visibility, reports. And again, not just at the project level, but then aggregating that data up so that you start to implement this across multiple projects. You start to understand the trends around risk, around productivity gains, and then you can start implementing best practices to say, going forward on all these high-rise projects, this is a best practice that we're going to implement because we see significant value there. And it really starts to add value across the whole enterprise.
Great, thanks. We'll go with one more question. What is included in Brickeye's service?
Diogo, do you want to take that one?
So in the Brickeye service, the preparation of the risk mitigation plan is the first step. We offer our service in the hardware as a service model, where we prep up all the equipment, we do the installation, we provide reports, software license, the the equipment, the rental. It's kind of like a rental model. All the sensors, all the automatic shutout valves, and that goes on for a certain period of time that's predefined with the customer. Either it's 12 months, 6 months, or 3 years, and the customer can cancel that service at any time. Right? We come in with specialized technicians. They're contractor check approved. There's insurance certificates and all the safety certifications or government certifications needed to work on a project.
Yeah, and just to add to that, I mean, as Diogo said, it is a hardware and software as a service, and it's typically on a monthly kind of basis, and so it really is customized to the project. And again, as different things are added or taken off the project as the project progresses, it really is adapted to your project and your project needs.
Great, thank you, guys. So that's all the time we've got for today. Thank you again to everyone for attending today's session. We encourage you to connect with us on social media. If you have additional questions or you'd like further clarity, you can contact us at sales@brickeye.com. We would be happy to provide you with additional support. Thank you, everyone. Have a safe rest of your day, and we look forward to talking to you soon.
Thanks, everybody.
Thanks, everyone.